All right, good morning, folks. This is Tim Ealer. How y'all doing today? This satellite loop is kind of funky here. We're going to be getting our first visual on 91L this morning shortly. I'm going to keep an eye on this. 91L is struggling to consolidate this morning, and there's been a lot of talk on social media about this and where it's going to go and things like that. And model guidance is actually trending downward as far as intensity goes. However, given that the models are thinking that the cyclone will be weaker, it's likely to move to the south, like to the west more than it is to the north, because it's going to follow the level flow. Excuse me. And if it gets better organized and becomes more vertically aligned, the upper and lower level circulation, then we'll be able to, then it'll be more influenced by the upper level flow. So if you look at this is the water vapor here, you see there's a lot of dry air surrounding it. And I forgot to get my pen going this morning. Apologize for the interruption here. I've been looking for some good ways to visualize this. But we have dry air being pushed this way on the cyclone, and what looks like faster flow this way, and some vorticity down here. But it seems to be removed from the where the convection is. So quite disorganized still this morning, at least in my opinion. Going back to visible shortwave, you can almost make out what might be a low-level swirl here, but it could be a mid-level circulation. We'll have to see what first light visual images show with that. So as far as the National Hurricane Center latest advisory here for the Atlantic, in the short term, the system has a 60% chance of developing. This is 91L, or they call it AL91 as of 2 a.m. And 90% chance in 7 days. So we still have a long time to watch it. It's moving slowly westward right now, which is kind of unusual in the deep tropics. Usually it moves faster than that in the trade easterlies. So, and the let me fix this here. Well, Tropical Storm Lorena is here, still exists, I guess, and it's moving to the north here. It's gonna weaken the circulation but the moisture's forecast to move into the north here. I mean, into Mexico, right, and into the southeast eventually. And the flash flooding potential, you can see where the largest flash flooding potential from Lorena is. And I don't normally talk about these specific, but because of the potential impacts to the United States with flooding, it's worth talking about. Back to the Eastern Pacific, Kiko. Well, it's now they're talking about the direct impacts from winds are increasing, right? So, forecast being major hurricane through Sunday in the western Pacific Ocean. Soon they hit the Central Pacific, and so we'll have to keep an eye on this as it moves to the west here. But chances are, and I'll go over this again. I'll go over this. It'll weaken quite significantly before it reaches the islands, but we always got to be watchful for this stuff. So, like I said, I'll go over it here in a few minutes. Everybody wants to talk about 91L and hear where it's going to go, right? So that's what I'm going to talk about right now, where I think it may go in the short term. Models have consistently shifted to the south here over the past several days, likely due to being weaker than originally forecast. And this is all the major global models, probability of center location with 150 kilometers, multi-model ensemble output, right? So observed track, current position, and the model uncertainty is shaded based on higher certainty is in the darker reds, yellows, and you get further out in time, the model uncertainty grows. When you see the light blues here, that's where it is almost, there's no point in trying to predict it past this point. This is just track of 91L, right? So this is every member within these three global models and averaging a center here, and the you know, where each spaghetti plot, so to speak, ends up. So tightly clustered as you move through time here, it gets further out. You see what I'm talking about, a large spread here. Although I would say that given the fact that it's still weaker, the Caribbean needs to be on watch for this as it moves to the west here. And it really is dependent on whether it gains any strength in the coming days. And that's quite uncertain as of right now as well. And that can be seen by looking at the different models here. First, we're going to look at the all the hurricane models. These are models that are dedicated to forecasting hurricane intensity and other and are taking a lot other more storm-centered factors than the global models do. So they usually have a better handle on small-scale features, and on the outer part of the domain, they integrate the global model input into that and help us generate a forecast for intensity. So this is the HWRF. You see kind of fairly weak as we move through time here. Tropical storm maybe a week. Maybe Cat 1 hurricane possibly by reach the 10th of September here. Still out in the Western Atlantic. House A is another hurricane model. See, quite weak, becoming a depression on the 7th, 8th, coming a hurricane. House A wants to strengthen it for a little bit, then it weakens as it reaches the 10th of September. Likely due to either entrainment of dry air, wind shear, or the environmental factors that this model sees right now. The House B, however, which is just another model, hurricane model, and it has different parameters. It wants to intensify this rather quickly and into a strong either Cat 2 or 3 hurricane out here in the Western Atlantic and move it and re-strengthen it again as it moves towards the um, North Atlantic again. So this is probably the strongest model out of all of them. So I would consider this an outlier as far as intensity goes right now. We'll keep an eye on it. HMON's another hurricane model. Start out in time here. Depression. Maybe tropical storm. That's about it. So we already have the HMON. I pulled the GFS global model up. It gives you a better idea of global features, well, global perspective, right? So you have dry air. This is relative humidity values, deep moisture in the deeper moisture in the tropics with a moisture pocket surrounding 91L. Moves to the west, surrounded by dry air to the north, which is an inhibiting factor, really. And it never really. It finally gets a pocket of moisture surrounding it, but as it moves, it weakens as it moves over the Cuba and Haiti. And this model run wants to take it into South Florida. And don't take this as a forecast, but this is 2 weeks out. So make your own assumptions based on this, but there's no model that can depict where specific landfall point 2 weeks out. What's the Euro show from the operational run? Um, this is starting 00Z today. Wants to make it maybe a weak tropical depression moving through time. The operational run really doesn't want to do much with it. Really, it keeps it weak and just that's where the model run ends. So when we look at this, I been doing some research on this, and this is a GFDL model developed by the High Resolution Modeling for Earth to Local Domains, which is like a dynamic fluid model that the National Weather Service and NOAA is working on. And this is supposed to be a better depiction of what might happen with a storm. I know I'm getting in the weeds here, but I want to try to visualize this the best I could for people here. And what this is here is, I know it's kind of sorry. Um, hard to see, but this is just 91L radar reflectivity simulation, right? A lot of convection, but very loosely organized, going out 72 hours, 3 days. This system, it really doesn't show it getting very well organized at all. And if we look at the 10-meter wind as part of this simulation, that'll load it. Okay. This is storm centered, right? It really doesn't do anything with it. I don't, I'm not that impressed with it. But um, from a relative humidity standpoint surrounding the system, you can see the dry air to the west here of the system, right? It wants to keep entraining that dry air into it. And because it's dynamical, I mean, the atmosphere just behaves like a fluid, right? And there's a very good depiction of the fluid motion and the dry air getting entrained into the circulation and it not really getting going. Do a composite reflectivity with this system. This is just a total view throughout the whole atmosphere. See it move through time here. Just these are the highest reflectivity values that the system puts out, and that's what composite reflectivity does. You see that it's really not doing much. I'm quite surprised actually. So lastly, I want to show you the simulated infrared. This is just a higher colder cloud tops associated um, that the model simulates associated with this system, right? It um, doesn't look impressive at all. I know I'm saying that multiple times, but maybe towards the end of the run, but it's being quite disorganized. So I'm not too bullish on the system becoming much at all at this point. Um, Hate to be pessimistic. I know people are wanting to post stuff on social media, but this gives a more this gives a better idea that 850, the low level vorticity and high pressure steering currents at the mid levels, and the winds at 200 millibars, which is 40,000 feet up. Just the vorticity never really gets itself together here. So I know I don't sound that excited about it, but I'm not because um, there's so much model uncertainty right now. So, okay, in Kiko out in the Pacific right now. Um, Looks like it's entraining some dry air into its circulation. That's out. It's a fish storm right now, not really hurting anybody. If you know any fish out there, I might want to let them know. um, when you look at the long wave infrared, you can see the structure is kind of degraded over the past several hours. Continues to move basically westward here. So, um, likely just have fluctuations in strength as it moves to the west, northwest here. So, given that, I was going through this and I wanted to show best possible representation of moisture that may be accompany this system as it moves towards Hawaii. Here's the Hawaiian Islands over here. There's Kiko. There's the just a low pressure um, moving this way, right? Um, and move through time. It shows also the precip associated with it, right? So, excuse me. See the darker, get under the greens and oranges and yellows and purples. That's deeper precip amounts. See the circulation weakens as it moves towards the islands. Low level spin moves to the south through the big island, bringing precip over top of over the islands. And likely this will be the biggest threat from this system, right? Not the wind. And what's driving this is it can be depicted pretty well by the water vapor loop, right? not water vapor, relative humidity at the mid levels. See quite a bit of moisture at the mid levels, at least modeled as of right now. This is as of 00Z, so it's not the most up to date run, but it's close enough for our purposes here. Load and animate it. Very coherent structure. Starts to entrain some drier air. Upper level low to the west pulls a lot of its moisture up away from it, but it gets enough on the Hawaiian Islands where it could impact it. So, um, um, from a composite radar with relief activity and surface wind perspective, and this is the last one I'll show on this. You can see Kiko way out here. Very pretty intense circulation, starting to lose some of its symmetry here as it moves through time. Gets stretched out like I showed on the previous, but whenever it hits a high terrain of the Hawaiian Islands, all bets are off as far as flooding goes. So I think that's going to be the biggest threat in the coming days. So as far as the mid-level flow and its effect on sensible weather, let's go back to the beginning of this here. Sorry, guys. This is not behaving. There we go. So it's a different way to depict it I decided to use today. Trying to make this full screen. Apologize. So you have a mid-level, upper-level system out here, up here in Canada. Large high pressure off to the west here. You can see it. The 500 millibars going way up here. Trough going this way. Subtropical high out here. And 91L out here in the mid-Atlantic, Central Atlantic. When we go over time here, excuse me, that low spins into Canada. The low pressure builds into the west coast here, and the flow kind of flattens out, but you see some general troughiness. Looks like an upper level low developing in the southeast. We have what looks like another mid or upper level low to the north of where 91L would be. The low moves to the northeast up here in the continental U.S. Another low is kind of lifting out. And that's Monday, September 15th. So overall, you can see what happens here. Let's go through this again. Really, the general the trend for the trough or weakness in the dip in the jet stream over the eastern U.S. remains, with a high pressure briefly building in the upper part of the mid part of the country, which could bring some hot weather potentially there. That's just to the east. And maybe some warm weather building back in the east coast here. And we can look at that with temperatures here. Let's load it. And we have cooler temps to the north. Let's stop this real quick so I can animate it here. 90-degree isotherm, 100 degrees, 90, 100. Move through time. This is where the hottest temperatures are along the 90-degree line here. That's for highs, right? And the greens indicate cooler temperatures. See how it's cooling down for the good part of the nation here, where the lighter greens and the possibly getting into the 30s up here. And the northern tier. 90s moving to the south. See how the 90s being pushed to the south, almost just the deep south is forecast to be really, you can see where the higher temps are building in into the Midwest right here. Right here. See the cool air building down the spine of the Appalachians and to the much of the Northeast, the Mid-Atlantic. Hot temperatures building back in the middle part of the country. You see what I'm talking about here, what I talked about before. Moving to the east. In Mississippi Valley, low Mississippi Valley, getting quite hot. Hot temperatures return for that area for the long term. As far as reflectivity, what we're looking at is what you would see on radar simulated by the models. You see the greens and oranges depict the most moisture, the most area of convection into the northeast and along the Rockies here. But honestly, you got some going into Texas. And this is as of Monday on the northwest coast. And the upper Midwest getting into it here is that low. And the moisture, let's stop this right here. Let's go back. Bringing some moisture in here to the north as maybe a low pressure develops off the eastern seaboard here. And we can look at that with this particular. Go a little bit further out here. This is the maximum winds associated with this. And we can look at maybe simulated infrared. This will give us a better idea of what we're looking at as far as precip, like higher colder cloud tops. Shear, it looks like a low boundary, another boundary moving through the southeast. Wants to bring convection up the east coast. Another system moves to the flow to the east here. Maybe an MCS of some sort, or a low pressure developing along the Gulf Coast, moving to the north here. Likely non-tropical in nature. And then maybe a more potent system moving into the north, the Midwest and the northern high plains. This is almost 200 hours out, so you can see there's no real anything related to that tropical system according to this model. So I know it's a little bit different than what I'm used to showing, and the last thing I'll show here is total accumulated precipitation, right? So this will give us a good idea where the most precip is forecast to fall over the whole period of the model. Darker greens, darker blues, and you create more total precip. See where the most precip is expected to fall along the northeast, offshore Florida into the South Florida Peninsula, into the deep south, upper Midwest. Ohio Valley seems to be the only one that misses out on that. And this is the overall precip for the whole period. So the big winners for this are, at least according to this, of course, down in Mexico and in Florida. Some areas in the southeast or northeast quarter, the mid-Atlantic, and the Midwest and the Northwest. That's all I got for today, guys. I hope y'all enjoyed this and got something out of it. And have a good day.